Hey everybody, this is Larry. This is day 29 for the Leetcode Day Challenge. There's the weekly premium thing too, so we'll do that later. But hit the like button, subscribe button, join me on Discord, let me know what you think about this one. So yeah, first of all, I know some of you, I know I've been talking about it the last 3-4 days if you've been following. So thanks for the support everybody. I did do it, and look, it's a very cool medal. It's actually pretty colorful. I actually do like the medal. I mean, I don't know that I care about it that much per se, the medal itself. I ran a pretty good time for me because I only started running like 2 months ago, right? So I did. Yeah, I did. I ran and I only signed up 3 days ago, so I was not prepared too much for this. So given that those circumstances, I thought I did okay. I'm gonna now roll in, cut in some live action shots, and then after that we'll come back. Just behind me. Yeah. All right. Yeah. I don't know. I just like to share my joy. Hopefully, you appreciate it, not too. You don't hate it too much, or you just skip forward anyway. But yeah, let's take a look at today's problem, day 29. But yeah, I had a lot of fun though. I mean, it was a very beautiful day here in New York, as you can see from the videos, and maybe a little bit too hot even. And I was sweating out I was sweating a lot. But I did okay. But we'll see what happens. I don't know. It was fun. All right, let's take a look at today's problem. 2997. Minimum number of operations to make array XOR equal to k. You're given a zero-indexed integer array nums and a positive integer k. You can apply the following operation on the array any number of times. Choose any element of the array and flip a bit in its binary representation. Flipping a bit means changing 0 to 1 or vice versa. Return all the minimum number of operations required to make the bitwise XOR of all elements of the final array equal to k. Okay. What does that mean? I read the problem, but I didn't read the problem. So, okay. So let's say you have nums, you have a k, well, I have no idea what to say. Okay, so let's say we have this number, right? And the series, and we can flip one element from 1 to 0 or vice versa. I think the flipping thing. Oh, flip one bit. Okay. Whoops, I misread this. That's why I was confused. Because I misread this as flipping all the bits for some reason. And I was like, but that's not specified because because it depends on the number of prefix zeros if you flip all the bits, so it's a little bit awkward to define, right? Because for example, you have the twos, implements, or complements, which is, I don't know, just very confusing. Okay, well, the idea here is that, okay, so I think this is pretty straightforward, to be honest, and so it's pretty fine. But basically, the idea is that, okay, if you flip a bit, if you choose any element in the array and you flip any bit, it really doesn't matter which number you're flipping it from, right? Because it has the same impact as on the final result, right? Because for example, let's say we have this input, and I want to copy and paste it, but I want to change it to binary, right? So then you have 3, 2. Oh, what? All right, let me try again. So you have 2, 2, 1, 3, 4, right? And then now you're trying to get to 0, 0, 1, right? And so basically the idea here is that we need to do an XOR of the entire array anyway, right? So then now if we XOR it, then we have 1, 0, 0, right? And we're trying to get to 1. Well, it doesn't matter where you flip, I mean, because you could flip this from 0 to 1, you could flip this from 1 to 0, so flipping this 1 to this 0 just requires one operation. It doesn't matter, literally doesn't matter which element you choose it from, right? So you do, and then now 0 and 1, right? So it also, again, literally doesn't matter where you flip it from. You change this to 1, this goes to 1, and you're done. So that's basically it, really. So we just have to code it because it really doesn't matter. So then now we can do something like X for XOR, I don't know, C for current in nums, X, we XOR it with C, right? And now we have to XOR all the array. And then now, if you're clever and you're on the contest, you saw me during the contest, you could see that you can actually XOR K again and then count the number of bits, but you can also kind of write it more straightforward in basically, like, if you want to write something like maybe 32, 10 to the 6. What's 10 to the 6? 10 to the 6 is a million, so it's like 20, right? So maybe like 22. I like to kind of round up anyway. Well, not round up, but just like add a couple more so I don't have to do the math. But yeah, so then now if the ith bit of X, right, is greater than 0, is not equal to K bit, or the ith bit of K is greater than 0, then count increment, right? Something like this. And that's pretty much it. Because this is basically saying that if we have a 1 here, so well, what this does is that it gets on the ith bit whether there's a 1 or not, and if that's not equal to this, that means that they're not the same. Then we increment by 1, because then we can just shift that, or we could cause an operation on that bit. And those people who are familiar with XOR a little bit more will recognize that this is exactly the same as XOR, so that's why you can do an XOR on this. But yeah, that's pretty much all I have, though. I think I did this on a contest, and it was only a contest like 3 months ago, not even that long ago, to be honest. So you could probably check that video. Actually, I don't know, because sometimes I'm a little bit lazy on the contest, but an explanation. But yeah, what is the complexity here, right? This is going to be linear time, right? Because this is linear. This is linear. Well, this isn't linear, sorry. This is B, where B is the number of bits, but linear in size of K, I guess. So yeah, that's it. That's all I have for this one. Did I submit it? I think I submitted it. Some days I forget to submit it. No one tells me. But yeah, that's all I have for this one. Let me know what you think. Thanks for watching. Thanks for the support for the running and stuff. I'll have more beautiful updates for you out next. But yeah, I have to do the week. But stay tuned for the weekly challenge after this. So yeah, thanks. Stay good. Stay healthy. To good mental health. I'll see y'all later. Take care. Bye bye.